Welcome back to the Scotti-BYTE channel, and this is Scott. So it's a couple of days past Halloween, and I didn't have an opportunity to make a tutorial on Halloween. And so in celebration of that, I have on my pumpkin pie t-shirt. And after all, I really like pumpkin pie, even if it's not 3.14. So on the channel, I tend to cover a lot about infrastructure. And I don't really mention very often that I have quite a bit of home automation. In fact, between Zigbee and Z-wave devices, I'm probably topping around 200 such devices. That being said, there are channels that focus on home automation a little bit better. And yes, recently I have had a few such videos. And as one example, I have a couple of videos that talk about how to create an Incus virtual machine for Home Assistant. So anyway, in the process of all of my working with home automation, I have some pretty interesting stories to tell. A couple of years ago, my wife and I bought a new refrigerator. And we thought, wow, okay, we're going to buy a new refrigerator, but we don't want all these fancy gadgets on it. And in any event, they still call them out as smart refrigerators. And so we have a new Samsung refrigerator, and that Samsung refrigerator is capable of allowing you to check its refrigerator and freezer set points, to make changes to the refrigerator and freezer set points, and also to turn on the dispenser on and off, the water dispenser, and to turn off and on the ice maker. So all that sounds great. And I said, wow, a smart refrigerator, this is really great. But in a couple of years that I've owned it, every time I open the drawer freezer on the bottom, it seems like my timing is just wrong, and it decides to dump the ice tray at the point in time when the drawer is pulled out. And so I almost wish I could have an open source refrigerator with my own software and set up my own sensors and so on, so I wouldn't have something annoying like that occur. And the real question is, when somebody was engineering such a device, why did they never really think of that? Anyway, that's just a little bit of an aside, but this video is a little bit about my changing out my Nest Generation 1 thermostat that I bought all the way back in 2011. So in 2011, Nest came out with these fabulous devices, and I really have liked my Nest thermostat an awful lot since then. However, I ran into a few problems with it. Several months back, I got some emails regarding the fact that my Nest Generation 1 learning thermostat was going to be at end of life and essentially end of support. And so on October 25th, I wasn't really sure what I was going to experience, but I can tell you that I have been automating this thermostat through my Habitat Elevation Hub. And in addition to that, I had also written some API code, and I had it connected via the Google Home Automation connection. So I was pretty confident that when October 25th came around, that my thermostat was still going to be controllable, despite the fact that it said that it was going to be end of life. And so it says, what this means for you starting October 25th, your device will be unpaired and removed from your Nest app. Well, that was fine for me because I wasn't using the Nest app. And it said it was also going to be removed from my Home app, and that refers to the Google Home app. Again, that really didn't bother me either, since I didn't use either of those. And it said that you wouldn't be able to remote control the device, but you'd still be able to use it locally. Considering the fact that I had been using the API, I really didn't think I was going to have any issues, and I wasn't looking forward to actually swapping out this thermostat after all of that time. So come October 25th, I noticed that the Nest mobile app was no longer able to control the Nest device, which was fine because I wasn't using that. But of more concern to me, when I use Madam A, and I'm not going to say her name so as not to trigger your devices, I noticed that also my control ceased there as well. And that surprised me a little bit because I wasn't using the skill in Madam A. Instead, I was exposing that device through the Habitat skill, and it was on my Habitat elevation hub where I was controlling the thermostat, and that was using the API. So the point is, still, that device was a cloud device. So what they're telling you here is basically, hey, go out and buy another Nest thermostat. And although I love the controls on the Nest thermostat and I love its simplicity of design and its reliability, the thing that I didn't love about it is that it had a cloud dependency. And that cloud dependency meant that they could do things like end of life the device. I felt pretty confident that when they end of life the device, that I was not going to have my device suddenly stop working completely. And part of the reason for that is because I was using the Google Device Access API, and I was pretty confident that I was doing everything behind the scenes to have the device continue working. And after all, I really liked my Nest device because of its simplicity of display and simplicity of operation. And in fact, this device had been on the wall since the day it was released and the day that I bought it, which was back in sometime early 2011. And so I wasn't really anticipating the fact that this was going to become a completely dumb thermostat, which is what happened. When I removed the thermostat from the wall, I was very careful to document all of the connections that are here. And one of the things you'll notice, for example, is that when you do an installation of your Nest thermostat, they have various tabs here in blue that you can apply to your wires from your old thermostat, making it a little easier to install the new thermostat. And that was one of the details that I really liked, although you'll notice here that the yellow wire is marked Y1, and yet it's plugged into Y2. And that's because when I did that installation back in 2011, I accidentally mislabeled the wires. And so the other thing that's really nice here is the balance that's in here, and it's really interesting to point out that I had some foundation work done after 2011, and the house has shifted, so you can see here that the balance bubble is no longer aligned. It wasn't the thermostat that moved, it was the house that moved. Now that I had a great picture of the old thermostat wiring, I went ahead and removed the thermostat from the wall and spread out all of the wires so I could see exactly what it is that I had. The replacement thermostat that I chose was a Honeywell T6 Pro, and they have several versions of the T6 Pro. The version that I selected was the Z-wave version since it integrated to my home automation in the best possible way. A few design issues that I want to point out in regards to the Honeywell thermostat wiring block here is that it was a bit easier to put the wires into the Nest thermostat because it was a circular device and it gave more distance between each wire. It was a bit of a challenge to use the Honeywell T6 thermostat installation. And one of the things you'll notice here is that I have a Y and a Y2 and a W and a W2, which means that I have two-stage air conditioning and two-stage heating. Notice that the Honeywell mounting block here has no built-in level device to tell when the device is level. However, since it is not circular, that was just a little bit easier to do, and the fact that the wall had been painted earlier allowed me to align over those painted marks, which was where the original plate was mounted, and so I adjusted that ever so slightly since the house had shifted. I did make one installation error that you can see here in this particular picture, and that is that the red wire that you see over here is for the 24 volts off of the thermostat, and the brown wire is for the ground return for that connection, and I accidentally connected it to one of the auxiliary ports U, where it should have been connected to port C here. That had the effect of always having the thermostat running on battery and never running on the 24 volt power supply from the furnace. And so that caused my display to keep turning off. And no matter what software changes I made, I could never keep my display on persistently. And that turned out to be that wiring error. So in this updated picture here, you can see that I moved the brown wire from the auxiliary port U up to the C port, C for common, and that is providing the ground wire actually for the return for that 24 volt red wire from the thermostat power. And now the unit was powered properly and the display was turning on, and the installed batteries were only being used for a backup in the event of a power failure on the mains. The Honeywell thermostat had a little door that you can flip up to close the area where you could see the wiring previously. And although this sounds like a really great feature, one of the problems with that is that your wiring needs to be completely flat. With the Nest thermostat, that was a little easier because the design of the circular wiring panel made it easier to spread the wires out without problems. So I had to move my wires around and poke them quite a bit to get to the point where I could flatten the door that you see here. And now once I attach the thermostat faceplate to the wiring block and turn the mains back on, the display for the thermostat remained on continuously, as you can see here. Just a little bit of a comment about their user interface that I didn't particularly like. In this case, the setting for the thermostat happens to be 78 degrees, whereas the current temperature is 75 degrees. And what I didn't like was the fact that the current temperature, not the setting, is the one opposite the minus and plus, leading you to believe you would be adjusting the 75, and that was the setting of the thermostat. In reality, the setting for the thermostat is the 78 that you see here. And I would also like to have the setting of the thermostat be the slightly larger number. And sadly, there's nothing in the user interface that allows you to correct that, in my opinion, design error of the UI. It took me a little while to do the Z-wave settings for this particular device, and the reason is because I had to go into the menus and discover where it allowed the Z-wave device to broadcast for its pairing. And once I did so, the device was recognized, although it came in as a generic Z-wave thermostat in Habitat. But I was easily able to change that over to the Honeywell T6 Pro Z-wave thermostat driver. And later on, I also installed in Habitat Package Manager the advanced community maintained Honeywell T6 Pro driver, which was an advanced driver providing settings for many other features. My primary means of controlling my thermostat has always been by voice. And when it comes to home automation, voice has always been my preferred interface. And one of the reasons for that is if I have to grab a phone or a tablet and open an app and navigate in that app to the area where I can control my thermostat, why did I just not get up and walk across the room and control the thermostat manually like a caveman? So, what I did instead was I really prefer using voice. In my particular case, I have my thermostat defined as you could see earlier in Habitat Elevation. And then I used the Habitat Maker app to take devices from Habitat and make them available to Home Assistant, because Home Assistant allows me to do some more advanced types of automations. And in this particular case, you're looking at a Home Assistant dashboard that includes the control for my main thermostat, which is named Cat's Cooling Center. And there's a little tongue-in-cheek humor there because my wife always used to like to have the thermostat very cool. So we have here the thermostat being displayed through the Home Assistant dashboard, and it says that the current setting of the thermostat is 78 degrees and the actual temperature is 73 degrees, which you notice is kind of the opposite of how it is configured on the thermostat itself, which is what I like about this. And you can go down here and hit the minus and the plus to change things, but then I can also provide a voice command, so I could say, change Cat's Cooling Center to 74 degrees.
I've set the Cat's Cooling Center to 74 degrees.
And the Echo Show in front of me also shows the temperature on the thermostat just the same way as the Home Assistant interface does here. And likewise, I can change it back. I can say, Alexa, change Cat's Cooling Center to 78 degrees.
I've set the Cat's Cooling Center to 78 degrees.
And in my home lab, I have a 12,000 BTU Samsung mini split unit, and it's simply called Computer Room AC, and it's set to 61 degrees. And inside of my rack, even though I have fans, it runs right around 80 degrees, and inside of individual computer components, it tends to run about 90 degrees. And the drives that are running on my NAS are typically running around 100 to 105 degrees. And this is the reason why the computer room is kept so cold. And this really has kept me from having any sorts of drive failures. But the point here is that I have more than one thermostat in the house. Here we are on my Habitat Elevation driver's code section, and I have the advanced Honeywell T6 Pro thermostat driver, which I installed from Habitat Package Manager, and so Habitat Package Manager will maintain it. And as I understand, this is not under active development, but since the thermostat won't change in of itself, that's not really an issue. If I look at the driver code here, you can see that there's quite a few disclaimers about work that have been done and things that have been upgraded on it. And I found so far that this driver code is working great for the T6 Pro thermostat. That being said, the Honeywell T6 Pro not advanced driver is a standard part of the Habitat driver set, and so I used it as well. And here we'll take a look at what some of those differences are. I changed over to the built-in driver for the Honeywell T6 Pro Z-wave thermostat here, rather than the advanced driver so we could take a look at what some of the features are. And so we have settings for things like auto, cool, heat, the fan settings, emergency heat, setting the clock time, and so on. And then over here we have all the information on the current states. I have backup batteries installed, and so it's reading the battery at 95%. And we have the cooling set point, the heating set point, the current humidity, and idle brightness, which controls how bright the thermostat is when the thermostat is on idle, and so on, a lot of other features. If I move over to preferences, we can see that there's really not a lot here. We simply have the clock format, the debugging, and a couple of other things. We move over to device info, and then we can see we have the regular driver. If I click on this and simply type in Honeywell, I can go down to the user installed version of the thermostat, which is the advanced Honeywell T6 Pro thermostat. Now that I changed to the advanced Honeywell T6 Pro thermostat, if I scroll down the page, I can click Save and Close. And then I can come back here to the main listing, and it says Advanced Honeywell T6 Pro thermostat. If I click on the device again and I move back to preferences, now we have a long list of preferences here. For example, the schedule type, the temperature scale, whether or not your furnace has an outdoor temperature sensor and mine does not, equipment type, mine is a high efficiency gas furnace, and then talking about all the other settings that we might have here. For example, I have a 2-stage furnace, and we can go down through this list and see that there are lots of other values, many of which I really don't understand at all because I'm not a furnace tech. If we go back over to commands, again, these settings are all pretty much the same as are the current states. And if I go to device info, again, it lists the driver that we're running, and I can click in use by, and it shows all the various dashboards that I have connected to it. It has the concept of scheduled jobs, and of course we can always look at the logs, which tells us what's going on with the thermostat, and we can even look at the live logs by looking at the events, and it will tell us which things have happened out here. For example, if I change temperature, it will note when the temperature has been changed. And of course, now that we have the device in Habitat and shared over to Home Assistant, and the fact that in Madam A, I have the Habitat skill, and this device is shared over to Madam A, I'm able to submit all the commands that I would be able to submit to a thermostat. So rather than just necessarily checking the temperature, I can do other voice commands like, Alexa, what is the cat's cooling center set to?
The cat's cooling center is set to 78 degrees Fahrenheit.
Alexa, what is the temperature on the cat's cooling center?
The current temperature at cat's cooling center is 73.4 degrees Fahrenheit.
So overall, I like my Honeywell T6 Pro Z-wave thermostat after a couple of days of operation, and after I got over the rough spot of actually installing my power for the thermostat correctly, things started to work really well. I'm not really crazy about the physical controls on the thermostat or its front display, and I wish that those were modifiable things. But when you purchase any piece of hardware, you're always going to be bound by what that hardware does and how it is set up. However, it is my hope that the Honeywell thermostat, since it's completely locally controlled, will not experience a cloud end of life, as did my Nest thermostat, which caused me all of my issues. Although it is valid to point out that back in 2011, we really didn't have a lot of control over locally controlled devices like thermostats such as this, because most everything at the time was still cloud-based. And cloud-based is not an issue as long as you understand what the impact may be to you in your long run. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.